So in classful addressing, a large part of the available addresses were wasted. So as I have told in class A, there are 2 raised to 24 addresses. Class B, there are 2 raised to 16 addresses. And these are very large. 2 raised to 16 is 65,000 plus or 65K plus. And this is millions of addresses, 16 million something, 16 million plus. Okay, so these addresses are not utilized by the any network, and most of the addresses gets wasted. So that's why there is requirement of some other methodology by which these addresses can be used efficiently. Okay, so let us understand this. So the methodology that makes this more efficient use of the addresses is classless addressing. So till now we have studied the classful addressing with the help of class A, class B, class C, class D, and class E. Next, we are going to study the classless addressing. So these are the default mask for classful addressing. Okay, now what is a default mask that we will understand? In class A, default mask is 255.0.0.0. Class B, default mask is 255.255.0.0.0. So if you check your address, do we have that? So if you check your address, then you will get the address information like this. Okay, so if you check, if you can read this, this is IPV4 address, which we have read as 170.16.11.215. Then you will find this as a subnet mask. Subnet mask is 255.255.0.0. And one more is the gateway. Gateway will understand later in the transport layer. Okay, so it is giving you a mask also. Now, what is the use of this mask? So here also they are showing a default mask for classful addressing. So this mask is very important. Mask is used for calculating network address. Mask is very important to calculate network address. For example, say there are two, let us write this as switch. Some computers are connected to this switch. This switch is connected to a router. So this is a router here. So this is one network. Let us name this as network 1. Then this router is connected to some another router like this. This is connected to some switch. Then this switch is connected to some PCs. So this is switch. This is R0. This is router 1. Okay. So this we will call as network 2. And this one is a network 3, a network between router to router. Okay, now if you want to send, let us name this as A, B, C, and D. So if A wants to send a data to B, if A wants to send a data to B, then how this switch will recognize, or this router will recognize that this A and B are in the same network. So this is recognized with the help of the mask and a network address. So this will have the IP address as 172.16.1.1. This also have the IP address as 172.16.1.2. This is having the IP address as 192.168.1.1, and this is having the IP address as 192.168.1.2. Okay, so if A wants to send data to B, then they are in the same network. So switch will only take this data and will forward to B because both are in the same network. But if A wants to send a data to C, then the switch should forward this data to router, then router should forward to this router, and then this router should forward to here, and then finally it should be reached to here. So here it is very important whenever data is getting transferred. At that time, it is the first thing that is required to recognize that to which network that data belongs to. So if this PC is sending to this PC, then this data is belonging to the same network. But if this PC is sending to this PC, then data is belonging to the data is from this network, network 1, and data is going to network 2. So these are two different networks. So it is very important to find a network address for each IP address. It is very important to find network address for each IP address. And this network address is calculated using the mask. This network address is calculated using the mask. So that is the importance of a mask in your network. Okay. Now for class A, class B, class C, there are default masks. So these default masks are given as 255. That means all ones in the first decimal, 000, 000. Then 255, 255, 00, 255, 255, 00, 255, 255, 255, 0. And these are represented in CIDR notation. So let me write this CIDR notation as CIDR stands for classless intradomain routing. So this is another representation of this mask. So this mask can be represented like this, or this can be represented like this. Okay, so /8 means there are 8 ones in this mask. /8 means why it is /8. This 8 means there are 8 ones. If you count this, total number of ones in this mask are 8. Similarly, this 16 means there are 16 ones. This 24 means there are 24 ones in this mask. So the mask for class A is 255.0.0.0. Now find 255.0.0.0 for class A. So that we will understand here. Let me write some address of class A. Okay, let us write one of the addresses 10 dot. Addresses 10.10.10.10. Okay, so you can tell this as a class A address because first decimal is starting decimal is a 10. So that's why this address is of a class A. Am I right? Okay, now the mask is 255.0.0. So if we divide this address into network and host part, then you will find the division like this. These first 8 bits are in the network part, and this remaining 24 bits are in the host part. Am I right? That we have discussed in the last lecture. In class A, first 8 bits are in the network part, remaining 24 bits are in the host part. Now we have to identify a network part using a mask. So that's why this first decimal, or the first 8 bits are made as a 1. First 8 bits are made as a 1 here. Similarly, for class B, first 16 bits are in the network part, remaining 16 bits are in the host part. So, network part is made as 255, host part is made as 00. Similarly, class C, first 24 bits are in network part, remaining are in the host part. So, this 24 bits are in the network, all 255, and host part made as 0. So, remember in mask, the host part is 0, network part is 255. Host part is 0, network part is 255. Okay, now how to identify network address? So this is IP address we have been given 10.10.10.10. So this is IP of some machine or some device network of class A. Okay, class A. Okay, now what is default mask of class A? It is 255.0.0.0. So write this as 255.0.0.0. And in order to, so this is mask. And in order to find a network address, you will have to AND. You will have to perform the AND operation on these two addresses. And whatever is the result of ANDing, that is your network address. That is the network address. Okay, so for ANDing this, we will write 255. Let's write 255. Okay, sorry. First we will write 10. So write 10 in binary notation. So this 10 will be 0, 0, 0. Then 1 to 4, 8. This 8 will be 1. 4 will be 0. 2 will be 1, 0. Am I right? The binary representation for 10. 1, 2, 4, 8. So this is 2 plus 8 is 10. And 255. So 255 representation of 255 is simple. It is all ones. Am I right? This is 255. And perform the AND operation on this. AND. So AND, can you tell me the ANDing? So in ANDing 1, 1, if the both inputs are 1, 1, the result is 1, otherwise 0. If both the inputs are 1, then result is 1, otherwise result is 0. Am I right? Okay. So 0, 1 will be 0, 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 1, 1 will be 0, sorry, 1, 1 will be 1. 1, 1 will be 1, 0, 1 will be 0, 1, 1 will be 1, 0, 1 will be 0. So result is 10. Result is 10. So this 10 we have ended with 255 and result we have got as 10. Next, and this 10 with 0. So let us write this now as 0. Ending with 0 is very simple. 0, 0, 0, 0, 0, 0, 0, 0. So this is 0, and with 0. 10 and with 0. So this will be 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0. So result is 0. So this is 0. So can you tell me anything that is ended with 0? Anything that is ended with 0 will give the result 0. Because for result 1, both the inputs should be 1. Both the inputs should be 1 for result 1. If one of the input is 0, you will get result of 0. And this is 0, so you will be getting it as a 0. So remember this, anything ended with 0 will give you 0. Anything ended with 0 will give you 0. Anything ended with 0 will give you 0. And one more thing, anything ended with 255. Anything ended with 255 will give you the same number. So if it is 100 ended with 255, you will get 100. You will get 100. Am I right? So anything ended with 255 will give you the same number. So ending of the IP address is very simple. So here you have got the network address for this 10.10.10.10 as 10.0.0.0. So this is network address. Okay, now can you tell me a network address of our college? Let me write my IP address. So my IP address is 172.16.11.215. My IP address is 172.16.11.215. 11.215. Okay. Now what do you have to do? For finding the network address of college, you have to AND. So this is IP. Then you have to write a mask of class B. So mask of class B is 255, 255, 0.0. So let me write here 255, 0.0. And perform the AND operation. Anything ended with 255 will give you the same number. 16 ended with 255 will give you the 16. 11 ended with 0 will give you 0. 215 ended with 0 will give you 0. So this is network address of our college. So if anyone asks you what is the network, which network your college is using, so our college is using a network 172.16.0.0 of class B. Of class B. So I hope you have understood how to find a network address with the help of mask and how to remember the mask for class A, class B, class C. So only make a network part as 255, host part as 0. So in class A, first decimal is 255, others are 0 in class B. First two decimals are 255, others are 0 in class C. First three decimals are 255, others are 0. Am I right? Okay. Let us go further. In classful addressing, which is almost absolute. Classful addressing, which is almost obsolete. That means all, in other words, let me write this as obsolete means very few addresses are remaining. Very few addresses are remaining. Most of the addresses are utilized by different organizations, and there are very few addresses now. IPV4 addresses are remaining. So, which is almost absolute, is replaced with classless addressing. So that's why whatever the addresses which are remaining, those should be utilized efficiently. Those required to be utilized efficiently. That's why the new method of distributing the IP addresses is developed is a classless addressing. Instead of granting a network address to any of the organization, what is given? A block of address is given. And this block of address is given with the help of the classless addressing. So we will understand what is a classless addressing. So figure, let us check a figure first. So this figure is showing one block of the address. So the block of the address is starting from 205.16.37.32 and ending at 205.16.37.47. So if you check, this part is same, and this part is changing from 32, 33, 34, 35, 36, 34, 7 up to 47. So total number of addresses are 16. Am I right? 32 to 47 is a 16, if you can count. So total addresses are 16. So this is a block of the addresses. Previously in classful addressing, what was happening? If you allocate a class C address, then you will get 256 addresses. If you allocate a class C addresses, you will be getting 256 addresses. If you are allocating a class B addresses, the organization will get 2 raised to 16 equals to 60K plus addresses. And if address of class A is assigned, then 2 raised to 24 equals to 16 million plus addresses were given to the organization. And these requirements were sometimes it were beyond the capacity of the organization, and sometimes it were lesser than the capacity of the organization. So that's why for efficiently using these addresses, classless addressing is developed, in which you can assign the addresses in the range of power of 2. That means you can assign the 2 addresses to some organization, you can assign 4, you can assign 8, 16, 32, 64, 64, 128, 256, and so on. But with the classful addressing, you should be assigning at least 256 addresses, which is of class 6. 256 and more, 256, then 16K plus, and then 16 million plus, which is not efficient use of distributing the IP addresses. So that's why this classless addressing is very useful, in which you can allocate the addresses of the power to any power of 2 raised to any power of 2. So you can assign them as 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, and so on. Okay. Now, important things for the classless addressing. So this figure block shows in binary notation as well as decimal notation. Total addresses are 16. We can see the restrictions are applied to this block. The addresses are contiguous. So in classless addressing, the addresses needs to be a contiguous addresses. So if you start from 16, the next will be 17, 18, 19 up to let us say 24, 23. If you are assigning the 8 addresses. So this should be 16, 17, 18, 19, 20, 21, 22, 23. The number of addresses is of a power of 2. Number of addresses are power of 2. So total addresses are 16. So 16 is equals to 2 to the 4. So these addresses that you are allocating should be of the power of 2. So this can be 2 raised to 1, 2 raised to 2, 2 raised to 3, or 2 to the power n. N can be 1, 2, 3, 4, 5, up to 32. Am I right? 32, because 32 is the maximum number of addresses in IPv4. So it is a power of 2. And the first address is divisible by 16. So this is important here for classless addressing. That first address of classless addressing must be divisible of 16. It must be divisible of 16. So the first address when converted to a decimal number is this number, which when divided by 16 results in this. So how to convert the address into a decimal number? So it is easy to convert this address into a decimal number. For example, say, I will not convert, but I will tell you the method by which you can convert the address in a decimal number. Let us write our college address 172.16.69.78. Okay. So how to convert this address into a decimal? Okay, so if I have given you a number as 1010, so how you convert this number into a decimal? So you write this as, you write this expression as, so starting from this left, 0 into 2 raised to 0 plus 1 into 2 raised to 1 plus this 0 into 2 raised to 2. Am I right? Then remaining this 1 into 2 raised to 3 plus. Am I right? So in this way you convert this into binary. So this term will become 0, this term will become 0. 0 into anything is 0, so you are not required to calculate. This 1 into 2 raised to n is 2, and 1 into 2 raised to 3, 2 raised to 3 is 8. So this 8 2 plus 2 is 10. So like this we convert this binary number to a decimal. Now this we write like this because these are base 2 numbers. These are base 2 numbers. Binary numbers means, binary means base 2. Decimal means base 10. Am I right? Octal means base 8. And hexadecimal means base 16. Similarly, this IP address is base 256. IP address is a base 256 number. IP address is a base 256 number. If you want to convert this address into a decimal, then how it will be converted? This will be converted like 78 into 256 raised to 0 plus 69 into 256 raised to 1 plus this 16 into 256 square plus this 170 into 256 cube. So same thing we have done here, same thing we have done here, only we have what we have done. Here we have taken a binary base, here we have taken a 256 base. Why 256 base? Because the number range of decimal is from 0 to 255. That means total 255. That means total 256 number you can represent at every position. So that's why it is a base 256. And if you want to convert this number into a decimal, then you will have to convert like this. 78 into 256 raised to 0, this 69 into 256 raised to 1, 16 into 256 square, and 170 into 256 cube. So by this you can convert and then check whether it is divisible by 16. So if it is divisible by 16, then it is a proper classless addressing. So in classless addressing, you have to follow 3 rules, which are the 3 rules. The first rule is the addresses should be contiguous. So addresses should be continuous. Then address is a power of 2. The total number of addresses should be a power of 2. So there should be either 2, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and so on. So addresses should be a power of 2. And the last condition is the first address is divisible by 16. So this is the third rule. This is second rule. And this one is first rule. So first rule is they should be contiguous. Second rule is the address is power of 2. And third rule is the first address must be divisible by 16. Okay. So this is what about classless addressing. So classless addressing, why it is used? So classful addressing can give number of hosts in class C equals to 2 raised to 8 equals to 256. In class B, 2 raised to 16 equals to 65K. In class A, 2 raised to 24 equals to 16 million, and which is not an efficient way. So if you want to assign a smaller number of addresses, maybe some institute which has only 6 computers in their institute, and if you assign them a class C address, then how many addresses will be wasted? 250 addresses will be wasted because they want to connect only 6 computers, and you are giving them 256. And if you are giving them class B, then thousands of addresses will be wasted. If you are giving them class A, then millions of addresses will be wasted. So that's there is a requirement of assigning the addresses in smaller blocks of 2, 4, 8. So if the requirement of institute is 6, then you can assign them 8 addresses because addresses should be of power of 2. So you can assign them the 8 addresses so that only 2 addresses will be unutilized and 6 will be utilized. So the number of addresses those are unutilized in classless addressing is very, very less. So that's why the classless addressing is a efficient way. In IPv4 addresses, a block of address can be defined as x.y.z.t/n. Okay. So this x.y.z.t/n. Or let me give some realistic example of this. 172.16.69.78. So I will be using this. I've read this a lot, and then we should be able to tell what is the cyber-ROM address of our college. So this is the cyber-ROM address of our college. So /16 and mask addresses of class B. So class B have 16 number of ones in its mask. This is where we have studied. Class B have 16 number of ones in its mask. Class A have 8. Class C have 24. So your cyber address can be represented like this. So here in which XYZT defines one of the address and /n defines the mask. So this /16 defines the mask. Meaning of this is there are 16 ones in the mask. So 16 ones means 255.255.0.0. 16 one means these are 8 all ones and these are 8 all ones. So this is 255, this is 255.0.0. Okay. The first address in the block can be found by setting the rightmost 32 minus n bits to 0. Rightmost 32 minus n bits to the 0. So what they are saying, if you have the address as 172.16.69.78/16, then you can set the rightmost bits to 0, 0.0. So this is your network address or first address. Network address or first address. Where n is number of bits for host. Number of bits per host. So this 16 indicates number of bits in the network. Okay, so if you write the another address as 192.168.32.10/24, so this is class C address, so /24. So what will be the network address of this? So you have to make the host bits as 0, 168.32. So there are 24 bits in the network, so remaining 8 bits will be in the host. So this last octet will become a 0. So this is the network or first address. Okay. A block of address is granted to a small organization. we know that one of the addresses 205.16.37.39/28. So this is a classless addressing. What is the first address in the block? What is the first address in the block? Now this is important. Now it is this mask is different from the default mask. So if class A default mask is of /8, class B default mask is of /16, and class C default mask is of /24. But this one is different. It is at /28. So what is the first address in the block? We have been asked what is the first address in the block. Okay, for that reason, we will have to represent this address in a binary form. Or let me tell you a shortcut trick. Okay, so this is 28. So what is this 28 means? 28 ones in a network part. So this is a network part. So what will be a host part? Host part equals to 32 minus network part. So 32 minus 28. So host have only 4 bits. The host have only 4 bits. So you have to make the last 4 bits as 0. We have to make the last 4 bit as 0. So this will be a same 205.16.37.39. This will be same. It will not change. Sorry. Up to 37 it will be same. And this 39 will represent in binary notation. So let us draw this 8 positions: 4, 5, 6, 7, 8. Okay, so 39 we have to represent, which is lesser than 128, so this will be 0. Lesser than 64, this will be 0. Then greater than 32, so this will be 1. So we have represented 32 out of 39, remaining is 7. So this 16 will be 0, 8 will be 0, 4 will be 1, 2 will be 1, 0 will be 1. Okay, so this is number 39. So if you count this 1, 2, 4, 32 is a 39. So this is a shortcut method. You will adopt this method once you have enough practice. Okay, so this is a number. Now, what is the first address in the block? So to find the first address in the block, what is required to be done? Make this rightmost bits 0. We have to make 4 rightmost bits 0. So this will become as 205.16.37.0010, and the rightmost 4 bits will be a 0000. And this will become 205.16.37.32.32, not the dot, 32. This number is a 32. Am I right? 1, 2, 4, 8, 16, 32. So this is a 32. So your first address is a 32. Okay, so 205.16.37.32. Am I right? Okay, so what was the question? A block of address is granted to a small organization. We know that one of the address in this block is 205.16.37.39.28. What is the first address? So to find the first address in the block, you have to first find the host bits. So this whatever slash notation is given, these are given as number of ones in the mask. So number of ones means what is the network part, number of bits in the network part. So number of bits in the network part are 28. And total number of bits are 32. We know the IP address is of 32 bit. So for finding the host, you have to write this formula as number of bits in host is equals to 32 minus number of bits in network. So this is equals to 4. So you have to make the last 4 bits as 0. So last 4 bits, that means this is not going to change, this is not going to change, this is not going to change, only this will change. Why it will change? Because we have to make last 4 bits at 0. So we have just converted this 39 into binary format, and then we have made the last 4 bits as 0, and then again we have reconverted into a decimal, and this is your first address. I hope this is understandable to you of finding the first address. Or other method, you can mask. Okay, how to mask? Let me tell you the other method also. So network part have, mask have 28 months. So 28 months means this will be 255 here. Am I right? 8 months. This will be 255 here. Another 8 months. This will be 255 here. Another 8 months. And this will be having 8 plus 8 plus 8, 24 months we have written. Remaining 4 ones here and this as 0. So another method of finding the first address is ANDing with a mask. Is ANDing with a mask. So this is IP address, and this is masked with the subnet mask. So subnet mask is 28 ones means 255.255.255. These 4 ones, 4 zeros. So and this you will get 205.16.37. This will be 0, this will be 0, this will be 1, 0, and these are all zeros. Am I right? And this in turn you will get 205.16.37.32. So this is the first address. Is it clear? Okay, so same is the solution they have given. So it is a 32. So let me check by which method the solution is given. So if you can read this, read it. The binary representation of the given addresses. So they have represented a complete address, but representation of complete address will take a lot of time. So it is not required to convert it completely. Only we are concerned with this last decimal. So we have converted this last decimal to binary. Then if we set 32 minus 28 rightmost bit to 0, so they have made calculated the host bits 32 minus 28, which is equals to 4, and they have made it at 0. Or 205.16.37.32. So this is the address that we had calculated. First address. I think address in the block is found by setting the right most 32 bits to 1. So if you want to find the last address, you have to make this last 4 bits as 1. So this last 4 bits are made as 1. First address, all the 4 bits will be 0. Last address, all the 4 bits will be 1. And the last address is 47. Number of addresses is calculated by using a formula. So this we will learn in subnetting also. So I think we should stop with this. We have learned, conducted 2 lectures of the same subject, basics of computer network. And it may require the 10 to 20 lectures to completely study this IP addressing. So I will suggest you to go through the Porzan's book of TCP IP protocol suite. So I already have given one Porzan's book whose name is Data Communication and Networking. In that book, you will find the first 3 units that are neatly given very good. And for studying the last 3 units, you should use the same author's book, but with other title, TCP IP Protocol Suite. Okay, so I will share you that book also with you, soft copy of that book. And that book is very, very good. That is one of the reference books that you will be very interested to read. Okay, normally the reference books we find difficult, but this TCP IP protocol suite is a kind of book which is written in very, very easy language and very much in an interesting way. If you try to solve the exercises given in the book, then you will find furthermore interest. And I expect that you should be solving those exercises for the better understanding of computer.